People are wondering what's happening with 3I Atlas, and as of today, we have observed many behaviors that typical comets simply do not exhibit. The information I'm about to share marks what might be the most pivotal week in the research of interstellar objects. Since the discovery of Oumuamua in 2017, two major events have transpired in the last 6 days that dramatically reshape our interpretation of what we're witnessing. First, a new object emerged between Earth, 3I Atlas, and the Sun. Discovered on November 2nd by Gennady Borisov, the same astronomer who identified 2I Borisov in 2019, the only confirmed natural interstellar comet. This new object was named C2025 V1 Borisov. It notably lacked a conventional cometary tail, with its orbital eccentricity measured at 1.0095 plus 0.0026. Although it is considered nearly interstellar, it likely originated from the Oort cloud at the far reaches of our solar system. For 6 days, observatories across the globe monitored this object, and 8 out of 10 observations reported a consistent feature. No tail, just a vivid, compact coma. Then, at perihelion on November 8th, it completely disintegrated, vanishing from observation. On that very same day, 3I Atlas experienced an eruption of 7 jets of plasma. To clarify what I stated during my segment on Newsmax this morning, the interviewer posed a question about whether 3I Atlas exhibited any maneuvers as it approached the Sun. I decisively affirmed that it did maneuver. It veered from the trajectory expected if it had solely been influenced by gravity. The velocity boost equated to a jet carrying 5 billion tons of matter. This is the recoil force required to produce the deviation we observed. The pivotal question followed shortly after. Is there another object? What of V1 Borisov? I asserted that the crucial inquiry is whether it released any smaller objects, probes towards the planets. Let me clarify my use of the term probes, rather than fragments or debris. When astronomers analyze comets, we anticipate specific behaviors. As a comet approaches the Sun, it heats up, causing volatiles to sublime and gas to escape, resulting in a visible tail that is pushed away from the Sun by radiation pressure. It's straightforward physics. However, 3I Atlas is not following this pattern. As of this morning, observers including Michael Jagger recorded at least 7 jets emanating from the object. Some jets pointed toward the Sun, others away, with some at angles that defy fundamental radiation pressure dynamics. Stefan Burns, a geophysicist closely monitoring the object, articulated that we should refer to it as jets, not as just a tail. He is correct. What we're witnessing is far more intricate than simple cometary outgassing. Allow me to present a technical analysis. If 3I Atlas lost mass through natural sublimation, enough to explain the observed non-gravitational acceleration, and since the jets are directed oppositely, the object must have ejected significantly more than 10 to 20% of its original mass near perihelion. The elimination of only a fraction of the ejected mass provides the excess momentum needed to generate the net acceleration. The remainder gets cancelled out. Therefore, we should have observed a substantial debris cloud, 5 billion tons of gas surrounding the object, bright and conspicuous. With hundreds of telescopes now at work monitoring it, if that debris cloud is detected, we'd conclude that it was a natural comet disintegrating near perihelion, and its composition would be clearly identified. Yet, if we fail to see it, the mass loss is minimal. Despite the acceleration, we have to entertain the possibility of technological propulsion. Chemical rockets are capable of producing exhaust speeds of 3 to 5 km/h, which is 10 times faster than sublimation rates on cometary surfaces. Ion thrusters can achieve speeds of 10 to 50 km/h. With technological propulsion delivering the required Momentum happens at higher gas velocities, necessitating far less mass to be ejected to achieve a similar acceleration. This test is binary. Either there's a significant gas cloud or there isn't. It's either a natural phenomenon or something technological. We're about to find out. Now, let's turn our attention to V1 Borisov directly, as this is where the timeline takes a turn toward the implausible. On November 2nd, Borisov discovered the object, and it was subsequently officially logged by NASA's JPL and the Minor Planet Center. The calculated orbit displayed an inclination of 113 degrees relative to the ecliptic plane, nearly perpendicular to the trajectory of 3I Atlas. The closest distance between their orbits is about 75 million kilometers, and without non-gravitational propulsion, these two objects were never closer than 225 million kilometers apart. To emphasize, V1 Borisov is not connected to 3I Atlas if it did not utilize non-gravitational propulsion. The measured non-gravitational acceleration of 3I Atlas is not sufficient to close that distance. However, we observed an object emerging exactly in between 3I Atlas and Earth from our perspective. It showed no tail, brightened quickly, over 6 days disintegrated at perihelion, and then vanished on the same day 3I Atlas activated its jets. I refrain from making claims without evidence. I am simply laying out the timeline. A fundamental uncertainty surrounding 3I Atlas is whether it serves as a technological mothership that deployed numerous probes into the inner solar system. If so, those probes would need to have been small enough to evade detection until sufficiently close, exhibit minimal outgassing, appear in strategic locations, and efficiently complete their missions before, possibly self-destructing or deactivating. V1 Borisov fits this profile. It emerged, was observed for 6 days, and subsequently disintegrated, while the parent object activated on the same day. Does this constitute definitive proof? No. However, it's a hypothesis worth investigating. That's why I've tasked my research team at the Galileo project to examine data over the coming months, seeking smaller objects near Earth that may have been deployed. Additionally, I want to discuss the color anomaly, as this remains one of the most perplexing observations. After its perihelion, 3I Atlas appeared bluer than the Sun itself, radiating 5 times brighter than prior to its closest approach. The Newsmax host inquired appropriately, wouldn't it naturally heat up as it neared the Sun? Yes. However, here's the vital point. Even after heating, the surface temperature of the object remains significantly cooler than that of the Sun's photosphere, which is around 5,800 K. We would expect it to emit a redder hue, as cooler objects emit longer wavelengths. This follows basic thermodynamic principles, but astonishingly, 3I Atlas glows blue, bluer than our star. This observation necessitates internal energy generation, producing temperatures exceeding 5,800 K, or it suggests emissions of ionized plasma, or possibly a mechanism we have yet to comprehend. China's Tianwen-1 orbiter captured images of 3I Atlas from Mars orbit on October 3rd, when the object was roughly 30 million kilometers away. These images confirm a blue-green nucleus, producing a cohesive, shimmering glow with no visible extended coma or jets at that time. Spectral analysis of the Chinese data indicated dominant blue wavelengths, which might signify ionized carbon or energy processes that are not entirely thermal. To clarify, comets scatter light through dust, which creates a redder appearance. A blue shift implies scattering by smaller particles, possibly plasma, or perhaps, but less likely, artificial reflectivity. The Chinese data substantiates the anomaly rather than dismissing it. I wish to acknowledge a significant point here. While NASA's Mars Reconnaissance Orbiter documented high-resolution images around the same period, those frames are still pending administrative clearance. In contrast, China released their data within days, exemplifying transparency, an essential element of scientific progress. Science transcends borders. The sky belongs to everyone. When one nation hesitates, another can step in and contribute, benefiting all of us as a result. Let's review what we know for certain regarding the trajectory and composition of 3I Atlas. Its discovery occurred on July 1, 2025, by the Atlas Survey Telescope in Rio Hurtado, Chile. The object was located 4.5 astronomical units from the Sun, near Jupiter's orbit. Its hyperbolic trajectory possesses an eccentricity of 6.137, the highest recorded of any confirmed interstellar object, surpassing Oumuamua's 1.2 and 2I Borisov's 3.4. This object is unquestionably interstellar. Perihelion took place on October 29, 2025 at 7:47 a.m. Eastern Time, measuring 203 million kilometers from the Sun, situated between the orbits of Earth and Mars, with a maximum speed of 68 kilometers relative to the Sun's solar radiation of approximately 770 watts per square meter at that distance. This substantial thermal pressure could vaporize surface volatiles on any natural comet, but one timing detail is exceptionally significant. Perihelion coincided with solar conjunction. Thus, the object was obscured behind the Sun from telescope observations during its crucial phase. Some have speculated this geometrical alignment indicates intentional spatial timing. I don't engage in speculation. I rely on observation, yet the alignment is mathematically precise. However, space-based instruments manage to capture essential data. NASA's STEREO, a spacecraft, the Solar and Heliospheric Observatory, SOHO, and the GOES 19 weather satellite all imaged the passage at perihelion. Observations from the James Webb Space Telescope in August revealed an unusual composition, rich in carbon dioxide, small amounts of water, ice, water vapor, carbon monoxide, and carbonyl sulfide. The James Clerk Maxwell Telescope detected a dramatic increase in hydrogen cyanide production rates, rising from 1.5x 1025 molecules per second in early September to 4.5 K 10^25 molecules per second by mid-September, approximately 2 Cl. However, despite this chemical activity, the object exhibited minimal visible outgassing, no substantial tail, no massive debris field, until it erupted in 7 jets on November 8th. I must bring attention to the rapid brightening. It constitutes another anomaly that contradicts standard comet models. Data from STEREO-A, SOHO, and GOES 19 indicated that 3I Atlas brightened at a rate significantly surpassing most Oort cloud comets. The brightness increased inversely with distance from the Sun to the power of 7.5, which is far steeper than the typical 2 to 3 relationship observed in natural comets. It exhibited 5 times the brightness post-perihelion compared to before, and in addition, it appeared bluer. If this were attributable solely to natural sublimation, we should see the gas, the tail, and the debris cloud carrying a substantial portion of the object's initial mass. The latest images reveal 7 jets. If these jets represent mass loss in opposing directions, the mathematics suggests that 10 to 20% of the total mass was ejected. Where is it? Hundreds of telescopes are currently observing, from Hubble and Webb to ground-based arrays across the globe. If 5 billion tons of gas were discharged, it would not escape detection. The December observations are anticipated to provide definitive answers. On December 19, 2025, 3I Atlas will reach its closest approach to Earth at 269 million kilometers, or 1.8 astronomical units. This presents our most favorable window for observation. Hubble and Webb will capture detailed spectra, enabling us to measure outflow velocity, mass flux, and composition of the jets with unprecedented accuracy. It will be straightforward to ascertain whether 3I Atlas is of natural origin or technological, based on these parameters, leading up to next month. Should we observe significant mass loss, we will confirm its classification as a natural comet. If not, we may be faced with something entirely different. And let me be clear about what something different could imply. Technological thrusters could generate the observable acceleration with significantly less mass ejected. The necessary momentum can be delivered via higher gas speeds. That's a testable claim, and science is based on falsifiability. I've been asked repeatedly about my probability assessment concerning 3I Atlas. Prior to the latest evidence, I assigned a 40% probability that it represented artificial technology. Has that assessment shifted? My response on Newsmax this morning was intentional. I am waiting for developments in the coming days and weeks, as more data will be gathered when it is closer to Earth. In a cosmic blind date of enormous proportions, it is far more prudent to assess when all evidence is available, rather than leap to conclusions prematurely. Still, I will emphasize that the pivotal question I posed publicly today is one that resonates. Did it release probes towards the planets? We must closely monitor the skies near Earth. NASA can keep track of the area surrounding Mars, and the Galileo project is set to analyze incoming data relentlessly. If smaller objects were indeed deployed, they would become detectable as they approach planetary orbits. We possess the instruments and expertise. We are vigilant. Following December 19th, 3I Atlas continues its outbound journey, and by March 16th, 2026, it will pass within 54 million kilometers of Jupiter. NASA's Juno spacecraft may have the potential to image it and utilize radio equipment to scan for technological signatures, radio transmissions, electromagnetic anomalies, anything that might differentiate between artificial and natural phenomena. By that point, it will traverse Gemini, heading back toward interstellar space. Now, let's address the political and public reaction. This aspect carries significance. Representative Anna Paulina Luna sent a letter to NASA on October 31st, urging the immediate release of high-resolution images and data for broader scientific review. She has been in contact with NASA and Pentagon officials and is advocating for the release of high-resolution images captured by Mars orbiters on October 2nd so that they can be accessible to the scientific community. This demonstrates appropriate oversight. Data transparency serves the interests of science and the public. Public response has been remarkable. I've received messages from around the globe, with parents sharing that their children are asking about 3 Atlas news as soon as they return home from school. Kids are requesting telescopes for Christmas so they can observe such phenomena themselves. This level of engagement illustrates the power of discovery to ignite interest in the next generation. When Kim Kardashian tweeted her inquiry about 3I Atlas, NASA replied within 11 minutes. Yet, when Congresswoman Luna sent an official letter, there was no response for days. This discrepancy reveals institutional priorities, which should not exist. Science is universal. Data ought to be shared openly to foster understanding, regardless of the ultimate classification regarding the nature of 3I Atlas. Whether it turns out to be a natural comet or something far more phenomenal, it has already proven to be one of the most scientifically consequential interstellar objects ever documented. Unlike Oumuamua, which was discovered while departing, 3I Atlas was identified while it remained 4.5 AU from the Sun, enabling us to conduct months of detailed observations pre- and post-perihelion. We understand its composition, its trajectory, that it maneuvers, and that it exhibits 7 jets in multiple directions. We've established it is bluer than the Sun, that it brightened 5-fold, and that an object appeared between it and Earth for precisely 6 days before vanishing on the same day the parent activated. These elements represent well-documented, reproducible facts subject to testing. The observations in December will yield the final data set we require: the debris cloud assessment, the spectroscopic analysis, and the outflow velocity metrics. We need only wait 6 weeks. As I mentioned on News Nation, may we hope that 3I Atlas won't present any unwanted surprises for Earth during the holiday season. That isn't an exaggeration. If this object did deploy smaller probes, we must ascertain their trajectories and intentions, should those exist. Planetary defense is not some science fiction concept. It's a responsible precaution in the face of uncertainties. I'd like to conclude with a philosophical thought, but first, let me clarify the precise technical framework for what we are investigating. The outflow velocity test is relatively straightforward. Natural sublimation of water ice results in gas velocities around 0.5 km, while carbon dioxide sublimation reaches approximately 0.8 km. These numbers represent the ceiling for thermally driven outgassing, while chemical propulsion systems operate within the 3 to 5 km range. Ion thrusters can achieve speeds of 10 to 50 km, and sometimes even exceed this with advanced designs. Should we measure jet velocities above 1 km/s, we would be investigating something beyond what natural sublimation could produce. This can be validated using Doppler spectroscopy. Both Webb and Hubble are capable of conducting such measurements. The mass flux test is equally clear-cut. If 3I Atlas ejected 10 to 20% of its mass, estimating the nucleus to be somewhere between 440 meters and 5.66 kilometers in diameter, most likely under 1 tokaminarka, we would then be referring to the ejection of cubic kilometers of material. A 1 kilometer diameter sphere possesses a volume of around 0.5 kilobothries. 20% of that, if composed of water ice at 0.9 g per cm3, amounts to approximately 90 billion klieg, 90 million tons. Conversely, we've estimated 5 billion tons are necessary to account for the observed acceleration, meaning either the object is larger than initially thought, the mass loss percentage is lower, or the exhaust velocity exceeds that allowed by natural sublimation. These options can all be measured. Moreover, the composition test would indicate intent. Natural comets are typically dominated by water ice, carbon dioxide and carbon monoxide, all observed in 3I Atlas. However, if spectral analysis uncovers unexpected elements, aluminum, titanium, or refined silicon compounds, this would point towards processing, manufacturing, or technology. Webb's infrared spectroscopy could detect metallic signatures. We are not dealing with philosophical queries. These are engineering metrics that must either correlate with natural processes or diverge from them entirely. The significance of December 19th cannot be overstated. We're not speculating, we're measuring. Now, my philosophical reflection. Sometimes discovery isn't about looking harder, but rather letting someone else observe from a different vantage point. China's Tianwen-1 provided a Martian perspective of an interstellar visitor, marking the first non-Western spacecraft to directly capture images of this phenomenon from deep space. An event with historical significance, not due to national rivalry, but due to what it symbolizes: humanity learning how to observe collaboratively. From Cambridge to Beijing, from NASA's archives to China's open data contributions, from Mars orbit to Earth-based observatories, we are developing the ability to utilize both hemispheres of sight. Earth represents one eye, while Mars signifies the other. With both vantage points observing the same object, we create a stereoscopic perspective, enabling a three-dimensional comprehension. This is precisely what we've achieved. The first interplanetary 3D dataset of an interstellar guest. The cosmos is instructing us in the art of observation, and perhaps when 3I Atlas eventually fades beyond Jupiter, it will leave behind a legacy of collaboration. Not as proof of extraterrestrial life or simply as another comet, but as a lesson in unity. The universe isn't affected by our borders, it asks only that we pay attention. And so here we stand, noticing, listening, and preparing for the next batch of data, due December 19th, 2025. Keep this date in mind. That's when we'll acquire further clarity, whether we confirm the existence of a natural comet with extraordinary properties that compel us to amend textbooks or potentially uncover something that transforms our understanding entirely. The moment is unfolding right now. Over the upcoming days and weeks, we will learn so much more. I've instructed my team to search for any deployed objects. I've requested NASA to monitor the vicinity of Mars, and I've advocated for complete data transparency. The critical inquiry remains: did it release probes directed towards the planets? This isn't speculation. It's a scientific endeavor. We are actively scrutinizing the sky, analyzing the data, and tracing the evidence wherever it may lead. In 6 weeks, we will come to our conclusion. Thank you for your attention. Remain curious and keep your eyes on the stars, for something from beyond the sun has just passed through our neighborhood, and it might not have been alone.